Hello, it's me. I was wondering if after all these years you'd like to meet to go over Slope-Intercept form. 'Cause I want you to get a good grade on the homework you complete. Alrighty, that's enough singing for now. I know math makes us so very happy that we can't help but be moved to song, but y'all have a problem set to get done, and I've got a video to get through, so let's get to it. For today, class 7 of Unit 4, Linear Equations in Slope-Intercept Form, Part 2. So again, this video is optional. You have a problem set to complete for me. However, if you are somebody that feels a little bit shaky, wants a little bit more practice, just wants to see it done a couple times, I got you. Let's work through a couple practice problems and oil up those gears. Cool. So remember, last class, all we were talking about was this new form of a line called slope-intercept form that was really powerful for us when graphing. Remind me, what does it look like? 5, 4, 3, 2, 1. Well, slope-intercept form of a line, of course, this guy is y equals mx plus b. So important things to notice here, the y value is by itself. In other words, it's isolated. I've solved for y. M, of course, is going to be the slope of our line. So the coefficient of x when y is isolated gives us our slope. And then this plus b over here will be, we identify as our y-intercept. And the idea, of course, being, well, if I know the y-intercept, which is a point on my graph, and I know the slope of my line, this helps graphing move a lot faster because I can plot my point and use my slope to help me build my shape. A couple of variations that we can do using this form. Well, if I give you a line in slope-intercept form, you might be asked to find its slope and y-intercept. So I am not going to pause at any point, right? I am going to continue through these problems. I would strongly encourage you, once again, to pause, give yourself a little bit of time to work through each one before you see me talk about the solutions. So if you want to pause, here's your chance. If not, y equals 4x minus 1/2. Notice I'm already in slope-intercept form. So all I need to do is figure out, well, what's the coefficient of x? In this case here, that 4 is attached to it, so I know that my slope, often represented by m, is equal to 4. And then this minus 1/2 here is going to be my value of b. So my y-intercept is negative 1/2. If I want to, I can, of course, express this as a point. To find the y-intercept, I know, what do? 5, 4, 3, 2, 1. Very good. Well, if I want to find the y-intercept, I plug in 0 for x. So that tells me the point 0, negative 1/2 is on my graph. Same thing over here. Even though my order of my terms is switched, the thing attached to the x, so the negative 3/7 here, this is going to be our slope. So slope is equal to negative 3/7. And then the number on the other side, right, that's going to be my value of b. So my y-intercept is 2. That tells me that the point 0, 2, if I want to express it as an ordered pair, is on my graph. And finally, y equals negative x. Well, if I have negative x, remember, I have a plus b here, but if there's no b, that means that I'm adding something invisible. Well, the invisible thing that's getting added here is, of course, a 0. And then the same thing for the negative x. If I have a negative sign in front of something, that really means that I'm multiplying it by negative 1. So, with these pieces of ideas in mind, what words? Negative 1 is going to be my slope, and 0 is going to be my y-intercept, which tells me that the point 0, 0 is on my graph. But I can also take this idea, of course, and work in reverse. Let's say that I want to write the equation of the line with a set slope and a set y-intercept. Well, remember, if I have my y equals mx plus b form, where m is my slope and b is my y-intercept, all I need to do is slot into that general form. So I know here if the slope is negative 5, then I'm going to replace m with negative 5 times x, plus my value of b here is 3. I can even get real wonky with it. If I have a slope of 71/256, well, I know that's my value of m. All I need to do is slot it into place. So 71/256 x, and then plus my y-intercept. My y-intercept is negative 3,000, so it would be plus negative 3,000 more efficiently written as minus 3,000. Cool. Moving on. Other applications of my slope-intercept form, let's do some graphing. So, say I've got y equals negative 2x plus 2. Notice this guy is already in the slope-intercept form. All I need to do is identify the slope. Well, the slope there is negative 2. So my slope of negative 2, I'm going to choose, again, remember, think strategically. Slope is rise over run, so rewriting 2 as a fraction is probably going to make my life easiest. I'm going to choose to rewrite this as 2 over 1. And then plus 2 here, there's my value of b. So if b is 2, my y-intercept is 2. That tells me that the point on my graph, plug in 0 for x, and you get your y-intercept here of 2. So all I need to do, remember to graph. If I have the point 0, 2 on my graph, that guy is right over here. All I need to do is use my slope to identify some more points. So if I've got a slope of 2 over 1, and it's negative, remember my line needs to be decreasing as I move from left to right. So say, for example, that I go up, right? My rise is 2. If I rise 2, I need to run either left or right 1. And in this case, if I want to make sure that the slope of my line is negative, I'm going to run to the left to balance this out. So that tells me there should be another point here. Again, remember to label the points on your graph. So this coordinate would be negative 1, 4. And using the other direction, if I chose to rise 2 by going down to balance this out, if I run 1 to the right, then this would be a way for me to identify another point on my graph. This guy has a coordinate of 1, 0. I've got my 3 points. They're all labeled on my axis. All I've got to do now is connect them with a line. Again, we're going to pretend that this line is straight and beautiful and perfect. This guy is the graph of y equals negative 2x plus 2. For full credit, again, remember to label your axes, include your arrowheads. So I indicate which one is my y and my x axis. Include my arrows to indicate both the line and the axes extend infinitely. Cool. Let's do some more. So say I've got this guy. Negative 6x minus 4y equals 12. Notice it is not currently in slope-intercept form, so let's say that I want to rewrite it in slope-intercept form and graph my line. So remember, the goal of slope-intercept form is really just to isolate the variable y. So I want to move everything but y over to the right side. Easiest thing to do first would be to add 6x to both sides. Remember, reverse order of operations. So that leaves me with negative 4y on the left side. By convention, I'll write the 6x first plus 12. And then to get y by itself, I just need to divide both sides by negative 4. I'm going to choose to divide each term individually to make my life easier because, again, to fit nicely into my slope-intercept form, I want to have something with the slope attached to the x. So that would be 6 divided by negative 4, whatever that is, times x, plus 12 divided by negative 4, well, that's negative 3. An easier way to write this, of course, well, y is equal to negative 6 over 4. That reduces to negative 3 halves x minus 3. So here is the graph of, or the equation, sorry, of my line in slope-intercept form. So this tells me that it has a slope of negative 3 over 2. Again, I have a negative slope with a rise of 3 and a run of 2. And then here I have a y-intercept of negative 3, which tells me that the point 0, negative 3 is on my graph. All I've got to do now is build that graph. So 0, negative 3 would be 1, 2, 3 units down on my y-axis. So here's my point, 0, negative 3. Label it with its ordered pair. Using my slope, I've got a rise of 3 and a run of 2. So same idea. Let's say that I rise by going 3 up. To make sure that my slope is negative, I would need to go 2 to the left. So that tells me that this point, whose coordinate is negative 2, 0, is on my graph. Let's say I went in the opposite direction, so I'll rise by going down 3. To make sure that my slope is negative, I need a decreasing line. I'll balance it by going 2 to the right. So that tells me that this point, whose coordinate would be 2, negative 6, right? 1, 2, 3, 4, 5, 6. Yep. 2, negative 6 is going to be on my graph. I've labeled my 3 points. All I've got to do now, once again, is connect them with a line. Once again, we're going to pretend this line is straight, but again, I'm not grading you on the straightness of your lines. I'm grading you on the accuracy of your points. Label our axes, y and x, draw our arrowheads, and we've built our graph. Cool. One more for the road. Let's say I've got this guy. 2x minus y over 2 equals 1 minus y over 3. Notice I've got some fractions here, but that is still doable. This is a proportion. 2x minus y over 2, 1 minus y over 3. Both of those are fractions. I can solve a proportion by cross multiplying. So I'm going to take 2x minus 4 and multiply it by 3. And then I'm going to take 1 minus y and multiply it by 2. I'm going to use parentheses here to make sure that the entire expression in the numerator of each fraction gets multiplied. If you want to multiply everything by the least common denominator, you could do that too. So 3 times 2x minus 4, well, I can use the distributive property to simplify this. This guy is 6x minus 12. And then on the right side, 2 times 1 minus 4, well, that gives me 2 minus 2y. Sorry, not 1 minus y. 1 minus 4. What? 1 minus, no, words. Good. Not 1 minus 4, but 1 minus y. I am not doing a retake. I've made it too far. This is the last problem. Okay, 6x minus 12 equals 2 minus 2y. Now, I just want to get y by itself. So the easiest thing for me to probably do is to get rid of this 2. So let's subtract 2 from both sides. When I do that, I get 6x minus 14 is equal to negative 2y. Divide both sides by negative 2 to get y by itself. 6 divided by negative 2 would leave me with negative 3x. Negative 14 divided by negative 2 is positive 7. And then negative 2y divided by negative 2, well, that just leaves me with y. Notice, even though my order is flipped, I'm still in slope-intercept form. I know that my slope here is still negative 3. Again, thinking strategically, probably wisest for me to rewrite this as a fraction. So I'll write this as negative 3 over 1. And then positive 7 here. So my y-intercept is 7, which tells me that the point 0, 7 is on my graph. So I'm going to go 1, 2, 3. Silly. 1, 2, 3, 4, 5, 6, 7. Here's our point, 0, 7. Because I don't want to go off my graph here, let's just find points to the right. Doesn't really matter, of course, but my rise is 3, so I'll go down 1, 2, 3. And my run of 1, so I'll go over 1 to the right here to make sure that my slope stays negative. So I have this point here, whose coordinate is 1, 4. Let's find one more point, so I'll go another 3 down and another 1 over to the right. So that tells me that this point here, 2, 1, is on my graph. Let's draw our line through these points. We're going to pretend that this line looks really good and is really straight and is really nice. There we go. Here's our graph. Let's label our axes, y and x. And there we go. We're Gucci. We've got the graph of y equals negative 3x plus 7.